This is a very quick video to discuss the point-to-point correlation feature in HTC communications. The idea of this function is to take a list of measurement points and correlate with the prediction levels. The main advantage of this feature is the variable receiver elevation. So most of the measurements usually they have fixed elevation. You're doing draft tests 1.5 meter above the ground or something like that. But this feature is accepting variable receiver height, which means you could apply it for drones if you're using drones for measurements or for validation of the antenna radiation pattern. A good thing about this function as well is that no prediction is required, which means the tool can do prediction in real time, point-to-point mode, and you can report the prediction level and the measurement level, and you can report the delta and the accuracy of your predictions. So let me take you to the setup. This is HTC communication, or you could be using HTC Warfare for that feature. This is the base station. In fact, you don't have to have a coverage for this to be used or to be displayed for the analysis process. All you have to do really is to draw a rectangle and then use the feature. Before I do that, let me show you the measurement data, sample of the measurement data that I did. So this is actually a dummy measurements. So you've got the name of the point of interest, and they've got longitude, latitude, receiver height, and you've got here the field strength, or could be power level in dBm, and finally the coordinate system. Default coordinate system of 4dec, which means WGS 84 decimal degrees. So this is the file I'm going to use to do the prediction against and also to do a correlation. So step number one, you click on the rectangle, select the rectangle, and then make a big rectangle where you think your measurement's going to fall. And then you go to, obviously you need to have the station that you're going to use to be activated. If you have more than one station, you could have more than one station activated. So now we go to the point-to-point correlation, and then you specify the file of interest that you're going to use. This is the measurement file. And here we can define the unit if it's dB microvolt per meter or dBm. So mine is dB microvolt per meter. And find a correlation, find the best correlation at X pixels. So here it means is the radius or the pixels that you need to be considered in the correlation process. So when the measurement actually is going to fall on specific pixel. But sometimes you've got GPS inaccuracies that you can ask the tool to look around up to X pixels. So here I'm saying up to 2 pixels. So you can look around for a best match. And that's pretty much it. The gain is usually 0. We normalize, make sure your measurements are normalized. But if you think the measurements are not normalized, you need to apply a gain, then you can apply the gain here. So if you hit OK, the tool will quickly produce a report. So that report is the name of the point of interest, the longitude, the latitude, the receiver height. And like I said, the receiver height can be variable. It's an input in the case from the CSV. And here you've got the measurement value and then the prediction value or simulation. So these are dummy numbers just to show you how it operates. 67 measurement, 85 is prediction. And you can see the delta here. And you can see here whether it's line of sight or no line of sight or near line of sight. So you can establish if you can use these measurements to validate antenna radiation pattern or just for predictions. So this is another example, 77 and 82. The delta is 5.1 dB. And then in the end, you've got the report specifying what's percentage of measurements are falling within plus or minus 6 dB. Okay, so that's pretty much it. If you have any clarifications, please feel free to drop an email.